This time I got a Toshiba 52-inch LCD TV. Now I know what you're thinking. You're thinking, oh, this is more of the Vestel crap. No, it's not. This is actually a Toshiba set. This is an older set, LCD, fluorescent backlit, none of this LED crap. This one was given to me. It's mine. I'm going to fix it and sell it. It's not worth a lot of money, but I don't have room for this crap, so I got to get it out of here. So let's see what's wrong with this one. This time I got a Toshiba TV. This has been sitting here for a while. It was dropped off, I don't know, a couple months ago, probably now. Just said here, you can have this set. If you can make it work, you can keep it and sell it. So, I mean, these aren't worth a lot of money, but it's a nice big set, so I might get 50 bucks for it because it is a big one. It's completely dead. Push the power button, nothing happens. There's no lights. So we got to go into the power supply on this one. And hopefully it's going to be something pretty simple. So I can get this piece of crap fixed and get it out of here, because I'm buried in big TVs that came in over the last couple months, and I haven't had time to get to a lot of them. And the ones I've been getting to, most of them are smaller sets. I end up having to give them away anyway. So the only revenue I make off anything like this is you guys watching to see what goes wrong with them. So I appreciate the views and appreciate you sitting through the ads, because that's what makes the channel possible, and the only way I make any money is from the views. Just getting that out of the way. Let's tear this one apart and see what's wrong with it. So this set is 52-inch. It's from 2009, July 2009. So this one is, what, 14 years old? Naturally, this is before LED, so it's not going to be an LED backlight that's at fault. On this one here, because there's no standby or anything, I'm thinking power supply. I already have an idea what it's going to be. It's more than likely going to be, there's a resistor with a built-in thermal fuse on all of these units, and they normally operate relatively close to, when they're operating, relatively close to the trip temperature for that thermal cutout. Thermal cutouts, after a period of time and age, will sometimes just let go, or if someone has got the TV mounted with a heat source around them, like a fireplace or a radiator or something that allows the heat to build up in the back, or inside a cabinet. Some people put them in cabinets and closing on the side. They don't get good ventilation. The set heats up. So it could be that tripped, or some capacitors, or anything. Could have been a power surge. Could be anything that's failed on it, but it's completely dead. I don't think we're going to have a backlight problem. I don't think we're going to have a processor problem on this. I think it's going to be power supply. Just saying that before I even open it up, just from my experience on working on these televisions in the past. So the devices I'm going to focus in on are these devices that look like resistors, but what they actually are is, well, they are a resistor. They're a wire wound resistor, but they have a thermal cutout strapped alongside of it. And what happens is, if they get over a certain temperature, they're part of the soft start circuit. So the resistor's there to limit the current. Usually it's a low ohm resistor, you know, only a few ohms. So there's not going to be much heat produced, but if something is drawing too much current, the resistor will heat up and the thermal cutout will go open. That's what they're designed to do. The problem with them is they fail for no reason whatsoever. There's nothing else wrong with the set. Could be a power surge came down or something. Because they do normally operate warm, they are a large resistor, so they do dissipate heat. They do normally operate at an elevated temperature. That's just the nature of the beast on how they operate. And occasionally the operating temperature will get close to, not necessarily more than the rated temperature where they cut out, but it could get close to the temperature where they're designed to cut out, and they will fail. And a lot of times these cutouts just fail for no reason. We've seen them on ovens. I had a fancy toaster oven there not that long ago that wouldn't heat because the thermal cutout had failed, and I had to go buy a new one and replace that. The thermal cutout on these can be replaced as well. You can take out the potting compound to get to the thermal cutout and replace it, and then put new potting compound in, which is typically what I would do, as opposed to buying a new one, because these are expensive. Right? I could buy the thermal cutout for a couple dollars, whereas buying one of these is considerably more money. I don't know the price offhand, but it's not going to be no $2 or $3 like a thermal cutout is. That's assuming that that's what the problem is, but you know, I'm pretty much going to look at that first. That's the most likely culprit, providing that there's no fuses blown. We'll check the fuses, of course, first, right? But if there's no fuses blown, then that's a good chance that that's where the fault's going to be. First things first, we'll just check the fuses. That fuse is good. That fuse is good. I think those are the only two fuses on this one. Next, we'll check the combination resistor thermal cutout. You see this one here is 94 Celsius. It's a 0.68 ohm resistor and a 94 Celsius. This one here is a 0.68 94, and I think the other one is the other one. The other one's it's a 1.8 ohm 94. So these are really low resistive values. How's this first one? That first one's good. How's the second one? The second one's good, and the third one is, where is it? It's back here. And that one is open. There's our fault. This one here, that one's open. So let's pull it from the set, and we'll take it apart and see if we can fix it. This is the 1.8 ohm 94 Celsius. So let's remove this first. I gotta heat up the iron. We'll pull that out, we'll take it apart. I'll show you the part inside, how it's failed, and we'll get a new one in there and get it fixed up. I took my Volt out last night for a cruise around midnight just to see how much range I could get on the battery. Because I put new tires on it. I did not put low rolling resistance tires on it, and I found my electric range dropped by about 15 kilometers. So I pumped the tires up to 40 psi, which got 101.5 kilometers on battery power, and it wasn't completely dead, but it was pretty darn low by the time I got home, which is not bad considering it's only rated at 80. So I was pretty impressed at how far I got on battery power. So we measure this with the meter. It's going to measure open. We already know that because I measured it in circuit, but for the hell of it, it's open. So let's get into this thing and see how they're constructed and what we can do to get this thing to run. I'm going to use a Dremel tool, and I'm going to just show you. I'm going to start this in here, but I'm going to take it outside because I don't feel like breathing all the dust. But I'm just going to use a Dremel tool to chisel my way in. Basically, we'll move that out of the way for now. And we're just going to I don't want to really create a bunch of dust in here, so let me get this taken care of. So this is what the part looks like once we get down to it. The side that's got the thinner of the two wires is the thermal cutout side. The one with the thicker of the two is the resistor side. So I've dremeled my way down here. You can see that if I put my meter across this, it's open, but it's closed on that side because that's the resistive side. There's the thermal cutout. So I'm just going to dig out the thermal cutout, and I'm going to try to find another one that's of close enough value to this that will be suitable, and we'll replace it and then put some cement over top of it and let it set up, and then it's good as new. We do need to put some cement in there though, because that provides a thermal conductivity to the thermal cutout, so that if there was something catastrophic that went wrong, it would heat it up and cause it to fail. And of course, if they put it over a fireplace, it'll heat up anyway. But that's just the nature of the beast. Let me get working on getting this little broken piece out, and we'll get a new one in there and get it working. There's the old one there. Let me see what I can find for it. So I'm putting some more cement back in. I had to be really quick when I soldered the part back in because, of course, you don't want any excessive heat on the lead going into it, because, of course, if you get excessive heat on there, you're going to melt it. So hopefully I didn't do that. We'll check it now with the meter, make sure that I've got a connection. I should have probably done this before I cemented it back together, but we're good. So I just have to let the cement dry. These come in two different styles. There's the larger ones, which are made out of metal, which are higher temperature ranges for ovens and stuff, and then there's these ones here. Okay, let that there set up for a bit. We'll reassemble the TV, and fingers crossed it's going to work. It's going to work. It's going to work for sure. Guaranteed it's going to work. Okay, I think it's time I can mount this part back onto the board. It's the cement is certainly dried up, and if you look at it, it's really difficult to tell that it's ever been opened up. If we look at one of the original ones here, right, and this one here, they both look about the same. Put the part back in the board, just like this, and I'll solder it back in. Right here is where we're working. This is actually on the standby power supply, this particular part. The other two are on the main power supply. So this is why we had no standby voltage, because this is what provides the soft start for the standby supply. Anyway, that's placed back on the board. Let's put the power supply back in the set and give it a test. It should start up, and that should be able to get this TV up for sale. As I say, I'm not making a lot of money on something like this. So a TV like this, a used TV like this, I'd be lucky if I made 50 bucks on it. I'd be lucky if I made 50 bucks to repair a TV like this. You know, if it was brought to me with that fault. It might make a repair like this might make me $80 to $100, but going and buying the part, you know, thermal cutout, it's a couple bucks. The one I used was actually out of another set. Right, it was another identical part. I just took it out of another one that was a different value, because this was a 1.8 ohm 94, and I took it out of one of these ones here, another one like this, which was a 0.68. Right, so that's why the pins, the leads are short on it. I just cut it off and solder it back on inside the body of the original one, because going in and buying a part for a couple bucks and wasting my time to go in and buy one and coming back to put it in there, I've got lots of old power supplies, and if I had one that was the same value, 1.8 ohms, I would have just changed it, but I didn't. The other ones I had were like 0.6, I think 0.68 and 0.47 were the ones I had. It came out of another television board. So same thing, just Dremel it out, cut it off, and replace it. Don't want to take the protection out, because obviously it's there for a reason. I mean, I can understand someone just wanting to put a jumper wire over it, and that would work, but it is a protection device, so you don't want to do that. Now, it is a protection device, I mentioned that. if it wasn't there, I mean, if you look on the set here, there's places for 3 of them, and 2 of them are jumpered out, right? Some sets only have 1. Not all markets have got them. Sometimes they have more than 1 in series with each other. If you look on the back of here, you'll see how this is hooked up. It goes from one to the next to the next. So there's 3 of them in series. So some markets, they have more than 1 of them in there. Other times they don't have them at all. Worst case scenario, if you were to remove that and something were to short, it would just blow the power supply anyway. It would blow the fuse. So it's not like it's going to be a fire hazard per se, but it could certainly have further damage if something were to fail in the set. If it was drawing too much power, for example, and the power supply, the transistors were starting to heat up. As a result, you could end up with the transistors overheating and blowing, and then you've got a bigger problem. You've got a power supply failure as opposed to just a thermal cutout failure. So that's why you don't want to really remove them, because this will go first before the output transistors. Right? In this case, this one is, I believe it's regulator. Where is its regulator? That's the rectifier. That's the bridge there. Is it this one? It might be this one. This is the main power supply here. Or is it over here? Maybe this one here. Maybe that one. Yeah, it might be that one that's on. Anyway, again, its job is, it would, if something was drawing too much current, if you had a short on the secondary, for example, and it was drawing too much current but not enough to blow the fuse, in theory, these will heat up and shut off. I've never ever seen one fail in that way though. Not once. I've never seen one fail. Typically, if a set's got a problem like that and it's drawing enough current to heat the thing up, well, usually it will blow the other parts first. The transistors will blow first, or the caps will blow first, and then the main fuse will blow. So I haven't ever seen one of these things fail for any reason other than the part itself just got weak, or the TV was mounted over a fireplace and the fireplace was on. That was a big common problem when these sets first came out and everybody started putting them over top of their fireplace. Nobody knew how to mount their TVs. So when you mount a TV over a fireplace, you have to make sure that the heat from the fireplace can't get into the bottom of the set. And that means that the bottom of the screen really has to be mounted within about 1 inch or lower of the top of the mantle. If you look at my set in the house, the bottom of my set is only about 1/2 inch off the mantle. And that was done intentionally so that any heat from the fireplace will come out and the mantle sticks out, the heat will be kicked out. It doesn't have a chance to sneak in behind. If you've got too much space, the heat will come out and it'll go back around and then into the back of the TV. And that was a big common fault when people started mounting TVs over their fireplace. And it still is for people that don't mount them right. Fortunately now most people have figured out, after burning out 1 or 2 TVs in a short order, that the reason they were failing was because they mounted them over their fireplace and they mounted them too high. Or they mounted them over a fireplace that had no mantle to kick the heat out. And that was the big problem when these sets first started hitting the market in the early 2000s, was premature failure due to overheating. All right, moment of truth. Is it going to pop or is it going to work? Power. I heard it click. I saw a light come on here. There's a light on the board right there. Backlight should kick in. I think the backlight's on now. Let's just see if there's anything on the screen. We got power because the light's on here. I think the set's on. Or was it now on? Maybe it's on now. There, the backlights just came on. Okay, the backlights are lit now. I can see them glowing through here. They're on dim because the panel, it dims them down. But the backlights are on. Let's connect the source to it and see if we get a picture. Oh, there you go. It's working. It's got a great picture.
Tammy's friend rushed to the area. Tammy.
Let's say after midnight.
Yes, that's got a pretty good picture. Okay, let's get the back on it and get this one back together so I can get rid of it. I think these ones, the back's going really easy. I don't like some of the newer sets. Doesn't get any easier than that. Alright, there we have it. It's all back together, ready to be sold. Thanks for watching. We'll catch you in the next one. Bye.